Okay, now we're recording. Okay, now share. Okay, so these are the main equations that we're working with. So, so let's talk about problem-solving strategy. Let's see here. Yeah, I kind of like it. We'll fill this out. So actually, before we do that, let's actually look at one of these problems here. We'll fill that out later. Let's look at the example here. A plane starts from rest. It starts at 40 meters per second in 10 seconds. How far did the plane travel during this time? So there are usually five. What you want to do is you want to consider 5 variables. The 5 variables are going to be x minus x0. That counts as 1, by the way. That's going to be your displacement. Your v, which is actually your final velocity. Your v0. Your t. And your a. Now, this problem. You got a question?
Yeah, well, there's a lot. Should be. I have my papers and stuff.
Looks like we have someone who's not supposed to be here.
I brought my charger, but no, there's more.
So we're gonna go back up.
I don't know what Bill is. See you, Bill. So, right. So those are the 5 variables we're working with. Now, what variables am I given here? If someone wants to tell me. So, Elizabeth, I see you there on the screen. What variables am I? What am I given? Which of those am I told?
The velocity.
Mm-hmm.
And like the rest, it's like the initial, or yeah, the initial.
So we'll write this down. Given initial, final, and when you say it's rest, what do we assume the initial velocity is?
0.
Mm-hmm. Right. And it goes to 40, of course.
Yeah.
And then, are we given time?
Well, yeah, 10 seconds.
And what do we want?
The distance, or like,
right, the displacement. We'll call it displacement.
Displacement, yeah.
And then I'm always going to say this. This is the strategy. Of these 5 here, so I was given velocity, final velocity, initial velocity, time. I want this. Which of those 5 variables is totally irrelevant for this question here? So, Kate, what do you think?
Acceleration.
Right. So now let's go to our kinematic equations here. We have 5 different equations here. Usually, I'll tell you right now, usually you're going to ignore this one right here. You're going to focus on, you may want to add this to your notes. You're going to focus on those 4. Now, acceleration is irrelevant in the first one because it's not involved. On the second one, x minus x0 is irrelevant. And the the second to last one, V is irrelevant, and here T is irrelevant. This is how you tell which equation to use. And I was kind of explaining to another student that like, yeah, like I just kind of would memorize this stuff and then really understand what I was doing. I got thoroughly confused and would use the wrong equations. I want to give you a strategy. Figure out what you want and what you have. Of the 5 variables, 3 of them you'll be given, 1 you'll want to find, making the 5th one totally irrelevant. That's how you tell which one to use. So if acceleration is irrelevant for this problem here, which equation am I using here? So Sophia, what do you think?
The first one.
Totally, thank you. That's what I'm going to do. So now I'm going to scroll back down. I'm going to erase this other junk here because we don't need it. So that equation was just hold on a sec here. Because my memory sucks. It just, there we go, X. So now they do the average velocity, mind you. That's okay. So the average velocity equals X minus X0. Remember, average velocity is just, you know, this. Sorry, that's supposed to be time. Bad. So my final velocity is 40 plus 0 divided by 2 equals X minus X0 over 10. So in this case, it's just going to be 20 times 10, or 200 meters per second. Sorry, turn meters to kilometer distance. So again, I had to use actually the second equation as well, but I mean, it's easy because I mean, obviously not my average velocity is just 40 plus 0 divided by 2. But that's the strategy. Now you're not going to do 40 times 10. How come I didn't do 40 times 10? So so Isaac, how come I didn't do 40 times 10? Why would that be bad to do 40 times 10?
I don't know.
Well, were we going 40 the whole time?
No.
Exactly. Now, if I was going 40 the whole time, then would I do 40 times 10?
No.
No,
Can
you
you
would.
explain how you set why you chose these 2 equations to equal each other? Like, how'd you get there? You kind of lost me.
Oh, because they both equal the same variable. Let me clear the screen right now. See, those are the same.
Oh, so you just isolated the average velocity.
Yeah.
Okay. That makes sense.
Now, if you're going 40 meters per second, the entire 10-second interval, yes, you do 40 times 10. Absolutely do. But we didn't because we went from 0 to 40. That's why you have to approach it that way. But we're going to do some more. Let's take a look at, ooh, that's a good one. Okay, so let's do our strategy again. So we're going to be very, very consistent here. Okay, to avoid an accident, car decelerates like that, blah, blah, blah. So A, B, B0, t. Now, of these 5, 3 of them will be given, 1 we want, 1 will be irrelevant. So Sean, I'll call on you here. What do we want? This problem here.
There's a lot of noise going on in the background right now.
So if we look at this question here,
Yeah.
what does the question want?
Sorry?
What does the question want?
It wants deceleration.
No.
Time.
Read the question first.
Well, to avoid an accident, a car decelerates
Okay.
from 0.5 meter per second squared
Mhm.
for 3 seconds and covers 15 meters of road. What's the car's initial velocity?
So we want initial velocity.
Yeah.
So I'll put a question mark here. Now, what am I given?
You're given.
The 3 numbers are given, right?
You're given acceleration or deceleration,
So
and you're given time,
and
also displacement.
great. So we know x minus x0 is 15. We know that time is 3. And by the way, why am I saying the acceleration is negative 0.5? Why not positive 0.5? Why is it negative 0.5?
Because it's deceleration.
Decelerating.
You got to read very carefully. Excellent. Thank you, Sean. So now, which one's irrelevant? Which one does not matter, Sean?
Final velocity.
Yep, we don't care about it. Very good. Now, let's look at our equations. Which one doesn't involve final velocity? This one has x equals half at squared plus v0 t plus x0.
Yeah.
That one does not involve final velocity. I'm going to use that one.
Yeah.
So that's the strategy. So I'm going to write it out, and I'm going to just plug away. Come on, let's see here. It's really the plus x0 on this side. So let me actually kind of bring it over to the other side here. So they're kind of together. Now we can plug away. X minus x0, that's 15 we've covered. Acceleration is negative 0.5 t squared. The initial velocity, we don't know. So we know our time. I'm tripping. We know our time, it's 3 squared. We don't know the initial velocity, but of course times 3. And you just do the algebra, you just work it out. So it's 15 equals, let's see here, that's 9. That's negative 1/4. I think it's negative 2.25. And because I cracked my screen, I can't really write too far. Move things around, 17.25, 3b0. Whatever that is. What is that? Is it, could someone tell me, is that 5.75?
Yeah, it's 5.75.
There you go. There's your initial velocity. So that's the strategy we're going to use. And we're going to do this in the groups very shortly. Let's look at one more here. Any questions so far, by the way? No? Okay. Okay. Let's see here. So a cheetah is walking at this 1 meter per second when it sees a zebra at 25 meters away. What acceleration would it require for it to reach 20 meters per second in that distance? Okay. So Farah, I'll have you help us out here. So again, our strategy, A, B, B0, T, x minus x0. Okay. So which of these, so first, what do we want in this problem, Farah?
We want acceleration.
Great. So put a question mark there. What am I given?
You're given the velocity.
We're given two different velocities, right?
Yeah.
So which one's which?
I think V initial is I think it's 25. Would it be 0 actually? Because
No, so let's read carefully. The tree is
Okay.
walking at 1 meter per second.
it's
So a meter per second is a velocity unit.
okay.
And so that's what it's doing before it sees a zebra, right?
Yeah.
So that would be its initial.
Okay.
But now it's hungry, it wants to eat.
Mm-hmm.
So how fast does it get up to?
It gets up to 1 meter per second.
No, it starts at 1 meter per second, but it wants to reach.
Oh, reaches 20 meters per second.
Right, reaches 20, good. And then are we given time here?
I guess because it's per
Then
second.
What is the time? Or is that a trick question? Because do you see any units?
No, I don't see any time, but it's like
Yeah,
per
it's supposed to be
second.
relevant. So what does the 25 represent then?
Can you say that again?
What does the 25 meters represent?
The 25 meters would represent then the x minus x0.
Distance, exactly. Good. Perfect. So that's why you really have to break this down very carefully. Now, let's figure out which formula to use. So we want the one that doesn't involve time. So it looks as though I'm probably going to use that last one there. V squared equals V0 squared plus 2a x minus x0. So I'm going to do V squared because that was irrelevant. We didn't need time. And then we just plug away. We're solving for a here. Our distance is 25. So you get 400 equals 1 plus 50a, 399. You just kind of keep going. And whatever that is, that's your answer. So our strategy, which now I can start finding out that. But any question about this one? No? Okay. Let me just move this. Okay. I'm gonna go ahead and clear that. So we're gonna start doing some of these problems in just a sec. So the exams are to determine which variables are involved. And I'm not sure why that's there. I'm just gonna get rid of that. Make a list of what is given or what can be assumed from the problem. Like if you're at rest, you can assume, your initial velocity is 0, so stuff like that. Identify exactly what needs to be solved in the problem, and find an equation or set equation that helps you solve the problem. And you want to plug the knowns with their unknown variable And the appropriate equation, you choose the one that is missing the irrelevant variable. That's kind of the big strategy. Choose one that's missing the irrelevant variable. Just like we did for the other three. So we have the 5 variables, A, B, B0, T, X minus X0 is lumped as 1. And 3 of those are going to be given. One you want to find, so there's the odd man out. That's when you want to just sort of just throw it to the wind. And don't worry about that last one. Not sure what else there. So now what we're going to do. Do you guys have all that? Or are you guys still copying? So this is how the best way you learn. You learn by doing, right? So you've seen it. I've called on some of you guys. You know, some of you guys struggle a little bit, but it's okay. You know, I had to kind of guide you through it. Now I'm going to totally hop in the rooms. I think I'll probably make 3 rooms because I think it's good to have multiple people. Plus, I don't want to repeat myself 6 times. So, okay, I'm going to stop sharing the screen. I'm going to go and clear it. And who are we missing today, by the way? Steve's not here. No Steve to heave. Okay, 4. Okay, so we'll do 3 groups of 4. I see it's 10:54 right now, so this is perfect timing. So I think what I'm going to want you guys to do, let me just take a quick peek here. I think we'll do maybe 10 through 14, those 5 problems. Yeah, we'll do 10 through 14. Yeah. So we're doing numbers 10 through 14 on 1-5. So the last 5 problems. Probably take a few minutes each, I guess, and then we'll, you know, I aim to do a lunch break close to 11:30. So let me make the, oh, Steve, shut up, great. So now we got 13 people here. Okay, so let me actually stop the recording. We don't need it right now. Or I'll